Let's look at a little video to help us get introduced to exponential functions.
Hey, how's it going?
It's almost March.
What does that mean?
I get to watch my favorite sport.
Oh, right, basketball.
No, I actually play basketball.
That does not look like you.
Swish!
So you like to watch the NCAA tournament with all the college teams?
Yeah, it's called March Madness.
It's fun to guess who will win each of the games. Look, there's my favorite team. Go Cougars!
My favorite team's gonna win.
That's a lot of teams. How many is that?
There's 64 teams that start.
So they each play a game. There's one winner for each game.
Half as many teams still playing, so 32 teams left.
Then they each play a game. Let's see.
Only winners are left, so half of 32.
That's 16.
Yeah.
And half of 6 teams are left. That's
The Elite 8.
Sweet 16, Elite 8.
Cool pattern in the graph.
My team won again.
So did mine. And that leaves 4 teams left. The final 4.
Sweet 16, Elite 8, Final 4. Oh, I get it. Terrific 2. Take that 2. Triumphing 2.
For championship game.
I wonder who will win.
Let the better team win.
That's a cool pattern. Hey, help me with my homework. I'm supposed to investigate plant populations. Do you have a favorite tree?
Oak trees.
Why?
I like the hats the acorns wear.
So if an oak tree drops an acorn and a new oak tree grows, we had 1 tree, now 2. The population doubles.
Keep track of those numbers.
1 oak tree drops an acorn, and then we have 2. 1 tree doubled. Each of those trees drop an acorn, and we double again, 4 trees. So you took what you had before and doubled.
I think the hats look like little berets.
These trees all drop an acorn. Double the 4 trees is...
8. 8 trees.
That's what I had before, doubled.
You can write that more efficiently. Called exponents. 1 times 2 cubed.
Oh, that is nice.
You doubled again. 16.
Yeah, so that's what I had before, but doubled.
4 to the 4th.
Right, then each of those trees drop an acorn, and double 16 is 32. Oops.
Need to use a bigger scale.
Yeah, hang on. Okay, I've rescaled and stuck all of our data down there. Now, I can fit the 32. And that's what I had before, doubled. And that's 2 to the 5th?
Yippers.
Now watch how fast I draw these. Ugh, Fine, I'll rescale quickly, and this time I'll give myself a ton of room. This doubling sure takes a lot of room. Okay, now the 64 shows up just fine. So, what I had before, and doubled,
That's 2 to the 6th.
now 64 doubles to 128, and it fits 2.
Nice job.
I'll just write it as an exponent. 2 to the 7th, right?
Uh-huh.
Those trees double to 256 trees.
Barely fits.
I had 7 2s before, so 8 2s, 2 to the 8th. Uh-oh.
I don't like the sound of that.
The trees aren't supposed to double. They're supposed to triple.
Yeah, you can do the rest on your own. I'm out of here.
Alright, so let's look at
My team won again.
So did mine.
the graph real quick.
That leaves 4.
2, take that 2.
Okay, look at this graph. Does this look like a straight line? No. It kind of has this curve to it. What's the lowest number that it'll be? 2 and then 1, because your championship game, you just have 1 winner, right? So would this be called increasing or decreasing type of graph? Decreasing, good. All right, so let's see if I can find the other one where we have, there we go. All right, what kind of graph is this? Increasing, yep. And is it a straight line? No, it kind of looks here, but then it just like shoots right up. That's what's called an exponential function. Think back to when COVID hit. did y'all ever remember seeing how the cases just dramatically increased, and that's why we had to shut down? That's a type of exponential growth of the viruses. So what I'm going to have you do is look at when trees triple. So I'm going to pass this out, and you are going to triple the trees, and then go ahead and create this table and create a graph. So I'm going to pause the video real quick and pass that out. Okay, it says on the left side, trees triple. If the trees triple each generation, find the number of trees in the first few generations and look for patterns. This would be considered generation 0. How many trees do we have for generation 0? 1 tree.
How did the tree get there?
So after that, we're going to go to generation 1. It's going to triple. So we have the original tree. 2 acorns are going to fall. So we are going to have 3 trees now. We're going to draw one more generation. And then after that, we can just write the numbers. So generation 2. So each of these have acorns that are going to drop. So we have the 3 original. How many trees will we have in generation 2? 9. Hope y'all are better drawers than I am. And each one of these have the acorns in them. I'm just drawing little circles for the acorns. Oh, that's an extra one. Whoops. So triples each time. So times 3, and then times 3 again. So that would be the 9 trees. So instead of drawing them, let's just go ahead and fill in a table. So we have the table here, generation. We have 0, 1, 2, 3, and 4. Number of trees. So they started with 1. So that's 1 times, and then it's tripling. So 1 times 3, which is 3 to the first power. Generation 1, so the exponent is 1, making 3. Generation 2 is our original 1 times 3 again, 3 squared, which gives us 9. The next one's going to be 1 times 3 times 3 times 3. 3 times itself 3 times. So that'll be 3 to the third power. And what does that equal? 27. Fourth generation. We're going to do that again. Our original 1, and then times 3 times 3 times 3 times 3. So how many 3s are being multiplied? 3 to the fourth power. And what does that equal?
81.
81.
I said it first.
Stop. So let's make a graph. Remember, the graph is going to be exponential. It's going to increase rapidly. So we've got to be able to graph these on here. So our generation is like our X value. So label the generation axis with X. So that would be X over here. Our number of trees is the y-axis, so we can put y here as well. So we can always relate this to like an x and a y. So our generation, we're going to start at 0 at the origin, and then do 1, 2, 3, 4. We can just go to 4. Now we've got to do the scale on the y-axis. We've got to be able to put everything from 1 to 81. So what should we go by? I'm not going by ones.
1, 3s.
3s, that's still going to take
Do 5.
a long time.
10.
10s?
10.
Yeah, I would say 10's pretty good. So 10, 20, 30, 40, 50, 60, 70, 80. That looks pretty evenly spaced out. So we're going to graph now. So 0 is with 1. So like right there. 1 is with 3. 2 is 9. Almost looks like a straight line. But then 3 goes up to 27. That's when it starts to do the curve upward. 4, 81. So it's tripling every time. So go ahead and draw a smooth curve to connect all your dots. And it has an arrow at the end because it's going to continue on and on and on to infinity. One other way I want to look at it is as a pattern. The pattern of numbers of the trees. So we start out with one tree. List it out as a sequence or a pattern. 1 and then 3. 9. 27. 81. I want you to do the next 3 numbers. Don't shout them out. Just go ahead and find the next 3 numbers. All right, so let's look and see what is the pattern.
Times 3.
Times 3. So I want you to go ahead and write the pattern down at the bottom. So to find the next number in the pattern, we're going to multiply times 3. And what do we get?
243.
Okay. Times 3 again. What's the next number?
728, 9.
729?
49. 29.
Okay. Because that would be like 3 to the what power? 1, 2, 3, 4, 5, 6. Okay, and then what's the next one?
2 down to 187.
Okay. Because that would be 1, 2, 3, 4, 5, 6, 7. 3 to the 7th power. All right, so now with your group, you are going to decide on the would you rather. So let's read over the instructions for would you rather. To grow a forest quickly, would you rather start with 10 trees that triple each generation or start with only 3 trees that multiply by 10 each generation? You have to be able to back up your information. So I want you to create a table and graph for each situation. All right, so let's see how y'all did. It's okay if you're not done. Let's all look at it together. Shh.
I keep one of these graphs.
Let's look at the generation and then the number of trees. So for the first one, this said we start out with 10, right? And then it says it's going to triple each generation. So going from 10, it's going to be 10 times 3 to get 30, right?
Yep.
Okay. And then the next one, it's going to triple. So this one's going to be 10 times 3 times 3, 90. Then the next one, the third generation, we still start out with 10, but then we're going to multiply times 3 times 3 times 3, which is 270. This reminds me a lot of this one. What's the difference between the trees tripling here?
They just didn't go up by enough.
Instead of 1.
It's 10 instead of 1. We started with 10 versus starting with 1. All right, then the fourth generation.
Equals 2,430.
No, 810.
Oh, I skipped one.
Okay, we're just going to 4. All right, so if we were to do it on here, 0, 1, 2, 3, 4. So kind of like we did the other one, but I'd probably go by hundreds. 100, 200, 300, 400, 500, 600, 700, and 800. So we start out with 10, so it's going to be down there. And then 30, then 90, then 270, and then 810, something like that. I like to do the curve with a pencil, just in case I mess up like I did right there. And there we go. Something like that. Let's look at the other scenario. It says we are going to start with only 3. So the generation 0, we're going to start with 3 trees. And then it says we're going to multiply by 10 each generation. So generation 1, we're going to start with 3 and then multiply by 10, getting us 30. They're equal right now, right? They're the same. We're even. The next generation, we're still multiplying by 10 each generation. So 3 times 10 times 10. So whatever we had before times 10.
300.
300. Next generation. Yeah. 3,000.
30,000.
Then the 4th generation.
300,000.
30,000.
No, just 30,000.
30,000.
Yeah, I know, but after that it's 300,000.
So when we graph this one, if we want to compare them, we need to do the same scale.
What do you mean?
By 100, but we're only going to be able to do 0, 1, and 2, right? And then it's going to shoot up. So let's just 0, 1, 2. Let's get up to 3 at least, 3,000. Oof, that's going to be hard, right?
Go by 200.
200?
Yeah.
It's still going to take
Go
200.
by 500.
Go buy 100.
500?
Yeah.
500, 1,000, 1,500, 2,000, 2,500, 3,000. So it's, I guess I should put, yeah, that's all I can do. All right, so 0 is with 3. 1 is with 30. So these are like down on the closest to the bottom. Then 300. And then 3,000.
I love the sound effects.
Mm-hmm. So then which one would we rather have if we want to grow the forest quickly?
3 trees with times that multiply by 10.
Mm-hmm. I would rather have
Question.
3 trees that multiply by 10 each generation. All right, so your assignment is going to be multiplication and exponents. We are still going to be looking at exponent problems. So make sure that you look at your notes if you've forgotten about how to do exponents.